Greetings to all. Today we're gonna see about the problem statement of the Smart India Hackathon, which have been proposed by the government of NCT National, uh, the government of Delhi, where the problem statement is about automated bus scheduling and route management system for Delhi Transport Corporation. So this is the problem statement description where they require efficient bus scheduling and routing plan and essential for the smooth operation of public bus transportation service. So currently, the Delhi Corporation lies on the manual method of scheduling and planning the time consumption and other stuffs like scheduling the buses to a specific route. They are doing it manually, so they are asking for an automated thing. So the our solution which have been proposed for this problem statement is, so this is the solution for problem statement. So our problem statement ID is SIH 1612. So where the real problem statement is in the metro cities, the bus transportation is having two crucial challenges, like the underutilized buses, which leads to the longer waiting times and higher cost, and overcrowded buses where passengers enter standing room only journeys, which states that there are two problems, like uh, in metro cities, the buses which have been sent to a specific route is not fully occupied, and in other hand, the buses which have been sent in another route simultaneously, it is not fully capable, like it will be not efficiently utilized, like um, for example. So I would like to explain with the example, like let's see, this is two routes in a metro city, like stop route 1 and route 2. Here in stop 1, well, stop 1, stop 2, and stop 3 and stop 4, sorry I didn't mention here. So like in stop 1, stop 2, stop 3 of a first route, there are passengers waiting of 30, 50, 20, and 50. So the cumulative account of passengers who are waiting here is 150. So this is this is the amount of passengers who are waiting in a first route is 150. And in same hand, so passengers waiting for number of passengers waiting in the second route is 55. The cumulative account, like 30, 50, 7, 3, and 10 of these overall stops. So these are the buses with capacity like 50, 12, 50, 12. These are the buses capacity 50, 120, 100, and 50 with seat capacities. So from this we can see that there are multiple stops in route 2, like single stop, one stop is higher than comparing to the first route, like it have three four stops, and it have five stops in the second route, like uh, actually what the manual scheduling will do means they will be scheduling high buses, more amount of buses to the route 2, because there is more stops. But here we can see that even though this route 2 has more stops, but the passengers waiting in each stops and the cumulative number of passengers who are waiting for the bus is less compared to the passengers who are waiting for the bus in the first stop, even though the stops are lesser than the second stop. So if manually alerting the buses will be alert high number of buses. Let's consider the buses with 50 capacities of two buses. It's 50 capacity of one bus, and 120 capacity bus of another bus, which is scheduled to the second route. So here there capacity of 170 passenger capacity in the bus, but it requires only 55 passengers in that route. But when we are scheduling these kind of things, like we will be scheduling one more thing, because the number of passengers who are waiting, the number of stops here is higher. But in this case, a single bus will be allocated, or the buses will be allocated to a first route, but it's not sufficient to fulfill the needs of the passengers of the count 150. So here the manual allocation failed. So in our project we are collecting the real-time data insights from the passengers. From that, we'll be count the enable dynamic resource allocation. Bus routes and scheduling can be adjusted on the fly base. Like actually, we will be collecting the real-time data of the passengers who are waiting for the bus in a specific route. Like in the once again, like here we can see that we will be placing a digital ticket counter in each and every mm, uh, bus stop, so the tickets will be purchased by the passengers. So that ticket details will be like this: the id, this starting route and destination. So it will be added to the database of the stops data by generating a QR code for each and every ticket, and the data ticket will be added to the stop data. Once the data is updated, the bus data will be static, like the number of buses and the count of static seat count and current count which have been filled is will be like that. And in second thing, that the data will be like if the passengers get into the bus, the QR code will be scanned once the passengers entered. Once the QR code is scanned, the tickets data will be updated, and the things will be deleted. The ticket data from the uh, thing will be deleted from the ticket data, and the data will be moved to traveling data. So from this we can know the real time data of the passengers who are waiting for the bus in a specific route. So for that we can allocate the buses according to the need of the passengers who are waiting for the bus. So by using this we can make this process automated, and also reduce like even like the overcrowding, and also reduce overcrowding, and make the consumption of the fuel efficiently. So this is the problem that we have addressed for and made solution for this. And our technology stack is front end. For the front end part we have used the React.js, backend we have used Node.js, Express.js, and database as of now we just use MongoDB, and the tools like GPS tracker. And for data security we just use a blockchain for this. So the feasibility is like this: the analysis of the feasibility of idea is real-time data. We will be collecting the real-time data of the passengers who are waiting for the bus, and the potential challenge and the risk strategies for overcoming this challenge are like this. So this is the challenge that we have proposed, and this is the impact on the impact and benefits of the project. Thank you.